School of G, every single grade, and that's the story of the evolution of Wade.
All right, welcome to BC Lesson 1-4, and we have, right off the bat, a variable times another variable group. Variable times a variable, that means, unless there's like a way to distribute and get out of it, of course, we're going to have to do the product rule. And this problem is going to be probably more algebra than it is calculus. That's part of the challenge. All right. If you could distribute the x squared, you would send the x squared into that parentheses. However, there's a 4 on the entire parentheses, which means somebody put a lock on the gate and you can't distribute and get in there, can you? Okay? If the 4 wasn't there, the gate would have been unlocked. All right, so x squared, high term. All this quantity to the 4th, ho term. All right, let's try it. Y prime. All right, so the rule goes ho d high. So ho term stays the same. Ho d high. Derivative of high. What's the derivative of x squared? 2x to the 1st. And it goes there. All right? Plus high d ho. High stays the same. Times d ho. Now, what's the derivative of just that parentheses right there? Anything to the 4th power, quantity to the 4th power, that would be 4 to the front times 2x plus 5. Let's do that first. So 4 comes to the front, base stays the same. Drops to the 3rd times the chain rule of the original base, and the derivative of 2x plus 5 would be 2 plus 0. So that's just 2 times 2 close parentheses, okay? And that's high d ho right there. All right, notice the one thing we did not do from the beginning, we didn't just take the 4 and just throw it down here to the front. No, if there's a variable in front of the parentheses, you would never bring the 4 down and try to do the rule we did in 1-1. It's not that easy. You've got to do the high and the ho. All right, calculus, done. Now it's all algebra. You've got to be strong in algebra to survive either AB or BC calculus. And guess what? You're all strong in algebra. You're in the right spot. Okay, so group A plus group B. Take out the greatest common factor. There's no way you can even distribute the 2x into this gate because somebody locked the gate with the 4. And somebody locked this gate down here. So, take out the GCF. First of all, I've got a 2x in this parentheses. What else do I have down here? I've got an x squared, a 4, and a 2. Tell you what, let's keep it simple. Let's just start with numbers only. The only number that can be siphoned out of group A is the 2. You can't pluck the 2 off the x right here because of the plus 5, and you can't pluck the 5 off because of the 2x. It's addition. You can't just pick off a piece of it, right? So only the 2 is technically multiplication. That's times on either side of it. Only the 2 can be extracted. Does group B have a 2? Yes. Either take this 2 or divide a 2 out of the 4, but don't do both. You have to pick one per group, okay? So I'm going to take out a 2, I'm going to take it out of this group, and I'm going to take it once out of this group. I'll probably grab the free 2 and not worry about the 4, okay? It's your choice. Now, let's go to the x's. That's a times x. You can't grab this x because it's with a plus 5. This is a times x, and that's an x squared. We could pull an x out of both, but we couldn't pull an x squared out of both, could we? That's too much. So I'm going to take out an x from group A, and if I take an x out of x squared, there's still 1 left. So we'll leave an x there, okay? And finally, now look at this big piece right here. 2x plus 5 quantity to the 4th, 2x plus 5 quantity to the 3rd. I could take out cubed, I could take out 3 of them, but I couldn't take out 4 of them because there aren't enough down here, right? So I'm going to factor out 2x plus 5 cubed. Out of 4, I take out 3, but there's still 1 left. There were 3 here. I take those out to the front. There are none left. And then in the parentheses, you put all your leftover stuff. But this is the greatest common factor right here. Okay? That's your GCF. Now you got to tell me what all the leftovers are. Now that you siphoned this out of both groups. It's the undistributive property. We're actually undistributing instead of distributing. Okay? All right, so in group A, the only thing left is 2x plus 5. And you don't even need parentheses because there's nothing else with it anymore. So you actually can just write down 2x plus 5. If you want to put parentheses, you can. You don't have to. All right, that's the sole survivor from group A. Then we had a plus sign separating the two groups. And the only thing left over in group B is an x times 4, and that's it. X times 4, we call that 4x. Okay? That's your leftover. So whereas the distributive property, if you were to distribute this mass back in here, you would get back to the original. Okay? Distributive property is multiply and multiply. Factoring out the GCF is divided out. We actually divided out all that stuff there. All right? And finally, one last step. And that is, those two are fine, but this down here, I had 2 cats, 4 armadillos, and 4 cats. Who says that? Oh, it's our old favorite game, by the way. Remember our old favorite game we used to play in my class called Mr. Wade's Farm, right? E-I-E-I-O. And on that farm, Mr. Wade had 2 cats and 5 armadillos and 4 more cats. Now, what kind of farm is that? It's a completely normal farm to say I have 6 cats plus 5 armadillos, all right? That was a classic we used to play all the time in my class. So 6 cats plus 5 armadillos, that's a normal farm. Normal farm. Okay, 2x, keep it. This quantity to the 3rd power, 2x plus 5, quantity cubed, you're good, okay? So don't go around telling me you have 2 cats and 4 cats. Nobody says that. Just tell me you have 6 cats. Look for those like terms. And if you had kept your parentheses on the 2x plus 5, there was no lock on the gate any longer, so that's why you could have just dropped it and added it with the 4x. And I didn't even put the parentheses, but you can, okay? All right, over here we've got letter B, y equals sine of 3x. Don't find the derivative. Find the 75th derivative. Whoa, what in the world, Mr. Wade? Okay, this is new to BC students. So, how do you take multiple derivatives? All right. Well, let's start with the first derivative. We've already said in this class that the derivative of sine is cosine. So the sine rule is sine goes to cosine, and the base stays the same always, but any base that stays the same, you must go back and address that. The derivative or chain rule of the original base 3x, what's the derivative of 3x? Times 3. There's your first derivative, okay? Let's do what's called a second derivative. Y apostrophe apostrophe, or prime prime. We call this y double prime. What the heck is a second derivative, right? The second derivative, which measures things in real life, by the way, and you'll see that later in my class. It's the derivative of the first derivative. Interesting. Okay. What did we say the derivative of cosine was? The derivative of cosine is negative sine, remember? What happens to the base? The base shall stay the same. What about that 3? We could have bumped the 3 up like a coefficient. We didn't because actually I'm trying to establish a pattern for you, but you could have. I'm going to show you why we're just going to leave it there for now. But what did we say happens When you have a coefficient, if it's there, don't coefficients just carry down to the next level always? Okay? So that 3 just carries down to the next level. You always keep your coefficients, all right? But wait a second. The derivative of cosine is negative sine, base stays the same, the 3 comes down because it was already there, times the chain rule. We never did a chain rule for this one. That 3 was the old chain of the last step, it wasn't the new chain. The derivative of the previous base 3x is times another 3. So when you do multiple derivatives, the chains keep coming out and the chain gets longer, okay? That's a real thing that happens in calculus. Now, the third derivative, also known as y triple prime. What is the derivative of sine? It's cosine, right? What is the derivative of negative sine? It's negative cosine. That might be the first time we've done this in BC. When you take a sine derivative, it stays the same sign, no pun intended, all right? Negative sine, negative cosine. Positive sine, positive cosine. Remember that. What's the base? 3x. What's the coefficient? 3 times 3. Really, that's a 9 up front. But just leave it. Just leave it. Think of it as a 9 if you want to. Don't the coefficients carry to the next level? Because you always keep your coefficient as you take derivatives. But we never did the chain rule. These were just the old chains. What about the new chain? The derivative of the previous 3x is another times 3, all right? These are multiplying against each other. Matter of fact, if anybody, my BC class, you are so just loaded with brain power this year. Such a bright class. If anybody is thinking that this is gaining exponentially, oh, you're at the top of the class right now, at least today, because it's exponentially increasing like the cockroaches back in my integrated 3 class, all right? Times 3, times 3, times 3, times 3, okay? Let's do the fourth derivative. All right, beginning with the fourth derivative, this is also called y quadruple prime. We do not make 4 slashes. Can you imagine in the 75th derivative, if you're going to have to make 75 slashes, wouldn't that be a waste of time? Starting with the fourth derivative, this is how we write it in calculus, and this will be true in college too. Hey, I'll use that gouge out of the board for part of my equal sign. All right, the fourth derivative, the 5th, the 6th, the 7th, the 8th, you put parentheses so that it's not mistaken as y to the 4th an exponent, okay? That actually means parentheses means fourth derivative, okay? What was the derivative of cosine? Wasn't that negative sine? So the cosine derivative always changes signs. So negative cosine's derivative is positive. I almost put cosine again. The derivative of negative cosine is positive sine. Base stays the same times the chain rule of the previous base. And the derivative of 3x is another 3. So you've got carry the 3, carry the 3, carry the 3, extra 3. Now, at home, if you don't want to write 3 times 3 times 3 times 3, is anybody thinking 3 to the 4th just to make it easier? See, usually by this point, like some calculus student has already said in the classroom, hey, make this 3 cubed, isn't that easier? Unfortunately, I don't have you all before me. I wish I did. But if you're thinking that, good job. 3 to the 4th. Okay, so that's the fourth derivative. What are we trying to do? We're trying to get to the 75th derivative. My gosh, this is going to take all day, isn't it? Well, let's go ahead and do the 5th derivative, and I want you to do something special. I do not want you to put it underneath. I want you to put it right across from the first derivative for a very good reason. All right. Now, if you just write that, that looks like y to the 5th. Oops. Parentheses. Now it's the 5th derivative. What's the derivative of sine? Isn't the derivative of sine positive cosine? What's the base? 3x. Base stays the same. What's the chain rule of the previous base? 3 So now 3 to the 4th becomes 3 to the 5th, doesn't it? Just at the moment that you think, my gosh, 75 derivatives are going to take forever, Mr. Wade, there's a pattern. Cosine, negative cosine, positive sign. It reset at positive cosine, just like the first derivative, didn't it? Guess what happens when you do the sixth derivative? You get a negative sign, because the derivative of cosine is negative sign. Guess what happens when you do the seventh derivative? The derivative of negative sign is negative cosine, blah, blah, blah. What's the eighth derivative? The derivative of negative cosine is positive sine, Okay, so there's a pattern here. It just goes in cycles of 4 forever. So you only have to establish the first 4, and then you can quickly answer the question. This is a classic on the AP exam at the end of the year that they like to ask to see who's thinking, all right? So what's the 75th derivative? Okay, the 4th derivative is down here. The 8th derivative is down here. Guess what else is down here? What's the next multiple of 4? 12. The 12th derivative is positive sign, okay? The 16th, the 20th, the 24th, the 28th, every multiple of 4 is at the bottom. Doesn't work with multiples of 3 or 2. You have to go with multiples of 4, but every multiple of 4 is at the bottom. Get to 75 as quickly as you can by multiples of 4, all right? That's the secret. Okay, what is close to 75 that 4 goes into? All right, I know that 4 goes into 64 for sure, right? We use that one all the time. 4 goes into 68. 4 goes into 72. That's about as close as we can get without going over. And you can also go over, by the way. Would everybody agree that 72 is divisible by 4? So the 72nd derivative, let's put a 72 right here. The 72nd derivative is at the bottom because 4 goes into 72. Now just go by hand. 73rd, 74th, 75th. Okay, the 75th derivative should be on this level right here. If anybody was super clever today, if you thought of the number 76 that 4 goes into, which most people that doesn't spring to mind, you could have labeled this one 76 at the bottom and then stepped back 1. That also works, absolutely. Okay, but go by 4s. So the 75th derivative, which is what we're trying to find, shall be on the 3rd level, which is a negative cosine. So final answer, 75th derivative. We said it was going to be a negative cosine. The base is still 3x. But how many chain rules have you done in 75 derivatives? You've done 75 chain rules, haven't you? 4th derivative had a 3 to the 4th. 5th derivative had a 3 to the 5th. 75th derivative has a 3 to the 75th to represent the 75 chain rules. And you're done. Right there. It's a clever problem. They like to ask it on the AP test. And they expect most BC students to get that one right. But it's interesting the first time you see it. It's not that easy until you kind of think about it and think, okay, I could do a cycle of 4. You know what? The only way you can miss it? Labeling the original equation, the original function, as step 1. If you label that step 1, 2, 3, 4, that ruins everything. Derivative 1 is step 1. Derivative 2 is step 2. Derivative 3 is step 3, and you're good. Okay, if you do that. All right, letter C. Y equals natural log of the quantity 7 minus 5x. The old natural logs from integrated class, of course. And, whoa, what's this? We have a new notation. Okay, what is this d squared y over dx squared? All right, that is fancy notation that we've never used before for the second derivative. That is actually y double prime, but in that fancy dy over dx that we've been talking about. So that's the second derivative. I literally cannot wait until the second semester, and we better be back to school in person by that point. I can't wait for the second semester where I get to show you why this squared is in the middle, but this squared is off to the side because they're in different places. Oh, it's so fascinating when you actually see this lesson in like February or March. It'll blow your mind. Seriously, BC Calculus is going to blow your mind this year. It is so fascinating. It is so cool. All right, so first, let's do, you know what? In the spirit of the equation here, in the notation, instead of writing y prime like we normally do, let's write dy over dx, because that kind of matches the spirit of this notation, right? dy dx, y prime. What did we say the derivative of natural log was? The derivative of natural log is 1 over the base. Remember this? This was like on day 1, 1-1, or maybe 1-2, one of those. So natural log is 1 over base. That is simply the natural log rule. But wait a minute. Oh, I guess I'll just go to my podium of bad ideas and write that down. Wait, Mr. Wade, remember our game? Hold on a second. Doesn't every derivative have, anybody at home, chain rule? You must use the chain rule for every derivative. You see that 7 minus 5x? Didn't you keep it the same when you put 1 over it? You kept it the same, 7 minus 5x? Did you ever take its derivative? No. Chain rule. Times, you must address the original base. What's the derivative of 7? Constant. 0. That's gone. What's the derivative of minus 5x, or even think negative 5x? Isn't that just negative 5? That's your chain rule right there. Okay? Let's clean that up, because that is negative 5 over 1. Shouldn't we just multiply it times the 1 on top? Let's just call it negative 5 over 7 minus 5x. Okay? That's your first derivative. All right? But they wanted a second derivative. So now we're going to do the second derivative with our new fancy notation. Okay, I need to take the derivative of this. Oh, wait. It's not derivative ready. It's not even in the proper form because we have an x on the bottom. Don't we want number base power, not number over base? Okay, what's your coefficient? Negative 5. What's your base? 7 minus 5x to the what? There was no power there. Oh, to the first. To get it ready for the second derivative, I bring it up. Does anybody at home know what power it goes to now? The negative first. Anybody? If you said that, you are correct. Okay. So this is the first derivative. This is the rewrite of the first derivative to make it ready. And now we can go to the second derivative. Negative 1 times negative 5. Positive 5. Base shall stay the same. Power, drop it by 1. It was negative 1 degree outside. Now it got colder. Now it's negative 2 degrees outside. Don't forget, it's in every derivative, the chain rule. We left the base the same like we were supposed to, but we never addressed it. What's the derivative of 7? That's 0. What's the derivative of negative 5x? That's a negative 5. Again, it's the same chain as before. It's another negative 5. Okay? So make sure you do the derivative of the previous base. Okay? All right. And now let's clean that up and make it official. 5 times negative 5 is negative 25, right? But this one is a negative power, and it says, excuse me, I'm going to go downstairs. And it's no longer to the negative second, but to the positive second. All right? And that is your final answer. Okay, for letter D, this is not for the faint of heart, that's for sure. This is only for the BC students here. This is a doozy. All right. What the heck's with this notation anyway? What is this? D over dx and then some equation right here, some expression. Okay. Well, we said before that dy over dx was the fancy way to write a derivative, right? And we have mentioned before that top means side. I mean, nobody would ever really write it like this, but technically that is the same thing with the y on the side. They've replaced y with the actual equation. So instead of dy dx, it's d equation dx. With all of you knowing that side means top, because I've been preaching that since like integrated 2 for some of you, okay? D equation dx, same thing. It just means jump into the derivative. It also means you can just put equals, because that's already y prime. You don't have to write y prime equals, okay? So what this means is just start doing the derivative. All right, now this one's kind of a tricky one. Tell you what, let's put this first off to the side. This one really needs an aside here because it's so advanced, all right? What's this? Oh, by the way, this is a variable times a variable, okay? Hi-ho, it's a product rule. Variable times variable group. Hi is going to be x. The ho term is what we call natural log squared of x. We did mention this in integrated 3. You surely did it in pre-calculus. Do you remember that the squared is actually a quantity squared? Because that's important. You'll never get through to the right answer if you don't know that, okay? So natural log squared is actually natural log quantity squared. That's important. Okay, let's try this. The rule is, for the product rule, ho-de hi plus hi-de ho. Ho-de hi. Ho term stays. Okay? D hi, derivative of x. Oh yeah, that's just 1. Or you could actually just skip it. Plus hi-de ho. Hi x times d ho. What's the derivative of a base squared? Just forget about the natural log of x for a second. Blank squared. How do you take the derivative of blank squared? Doesn't the 2 come to the front, right? It's, okay, let's put this in parentheses. 2 to the front. This is kind of a weird one here. Base, so 2 to the front. Base stays the same. The power drops from 2 to 1. So let's drop that. But wait a minute. Times the chain rule of the original base. You kept natural log of x the same, but you never addressed it. The derivative of natural log of x, we just talked about it. Derivative of natural log of x is 1 over base, which is x. And then technically, the derivative of x produces an extra times 1, but you certainly don't have to put that there, okay? But this right here, it was a double chain. That's why this one's so hard. That was the derivative of natural log of x. We'll call it dir of natural log of x, okay? So that's what that was. Okay, so that's kind of a tricky one right there. I expect there to be some questions on this one because it's one of the harder ones. The calculus is done. It's algebra time. Group A, Group B. 2 groups, factor out the GCF, right? But before you do, I hope your eyes catch this. Down here, anybody see anything we could do down here? Anything at all? I wish I had a class of actual human beings because this would be the point where some clever kid yells out, Mr. Wade, couldn't we cross-cancel the x's? Yes! Genius! I hope somebody said that at home. X and x. One's up high, one's down low, and this is all multiplication. It's x times 2 times natural log of x times 1 over x times 1. If it's all times, you can cross-cancel. Now, you can't ever jump across a plus or minus sign and cross-cancel, right? But it's all multiplication, which means you're all one group. Within a group, you can cross-cancel. You can't jump groups. You better cancel out those x's. X over x is nothing. Well, it's 1, but it's gone. Okay, much better. Now, before you do the GCF, get rid of that x, get rid of that x. Cross-cancel. Now, siphon out the GCF. Is there anything in group A and group B that's in common? Well, group A only has natural log of x quantity squared. That's all it has. Hey, that group has a natural log of x to the first. This has two of them. This has one of them. I could take one out of both, but I couldn't take squared out of both, could I? So we're going to factor out the natural log of x because that is the greatest common factor. That is the only common factor. First group, I had squared. I took one out. I still have one left. So you still have what? Natural log of x left. Plus sign. Drag it down here. Group B, anything left when I took the natural log of x out to the front? There's still a 2. That's gone. Oh, that's it. A 2. That's all you have left in group B. And you are done. That's your answer right there. One more minor note maybe right here. This is fine. But it's been established since the 16, maybe even the 1500s that you really shouldn't leave plus 2 after the natural log. Matter of fact, natural logs were discovered in the early 1600s. So that's about the time they would have established this rule right here. Doesn't that look like it could be natural log of x plus 2? Natural log of quantity x plus 2? Like, you know, we know parentheses, but that's confusing. If you give that to somebody else and they read it, they're going to say, did you mean x plus 2 together? Is that what you meant? Or did you mean the 2 is separate? So a long time ago, mathematicians decided that really for proper notation, you should never write natural log of x plus 2. You should write 2 plus natural log of x. Okay? Same thing, by the way, with sine, cosine, and tangent. They should come after. Now, is there any confusion? Isn't it crystal clear now that the 2 is not with the x? It's separate from the natural log. Okay? So that is an important mathematical rule. They will slam you in college a lot of places if you do this, so just heads up. I'd rather put that. In my class for the first test, I'll take either one for now.